Ever wondered how Netflix recommends movies or how Spotify suggests songs you might like? Well, the answer lies in the fascinating world of machine learning. Machine learning is a branch of artificial intelligence that gives computers the ability to learn from and make decisions based on data. It's like giving the computer a brain. This powerful tool is used in various platforms we interact with every day. Take Netflix, for instance. It uses machine learning to predict and recommend movies or shows you might enjoy, based on your previous viewing history. Similarly, Spotify uses it to suggest songs and playlists tailored to your unique taste in music. But how do these platforms achieve such accurate recommendations? The answer is a specific type of machine learning technique. It's a method that groups data based on similarities and differences, forming what we call clusters. The secret sauce behind these recommendations is a machine learning technique called clustering. So what exactly is clustering in machine learning, and how does it work? Let's dive into the details. Clustering is a type of unsupervised learning where data is organized into groups or clusters based on their similarities. Imagine a basket filled with fruits. You instinctively group similar fruits together, apples with apples, oranges with oranges, and so on. That's essentially what clustering does in machine learning. It groups like with like. But how does it achieve this? The process is threefold: feature extraction, distance calculation, and cluster formation. Feature extraction is the first step. It's where we identify the characteristics or features of our data that are relevant to the task at hand. In our fruit basket example, color, size, and shape could be features we extract to distinguish between different types of fruit. Next comes distance calculation. This is where we determine how similar or distant data points are from each other based on the features we've extracted. There are various ways to calculate this distance, such as Euclidean, Manhattan, or cosine distance, each with its own strengths and weaknesses. It's akin to determining not just which fruits are apples and which are oranges, but which apples are most alike based on the features we've chosen. Finally, there's cluster formation. Once we've calculated the distances between all data points, we can start forming clusters. The data points that are closest to each other form a cluster. The number of clusters we choose to form is crucial and can significantly impact the results. Too few clusters, and we might miss important nuances in the data. Too many clusters, and we risk overcomplicating things and creating an overly fragmented view of our data. Choosing the right number of clusters and the suitable distance metric is an art in itself, often requiring a mix of domain knowledge, experimentation, and intuition. In essence, clustering is all about finding patterns and grouping similar data together. It's a powerful tool in machine learning, and understanding its intricacies can unlock a world of possibilities. Now that we know what clustering is and how it works, where is it used? Let's explore some real-world applications. One of the most common uses of clustering is in recommendation systems. You know, when Netflix suggests a show you might like? That's clustering at work, grouping you with others who share similar viewing habits. Then there's customer segmentation. Businesses use clustering to group customers based on buying patterns, enabling more targeted marketing strategies. Another fascinating application is image segmentation. By clustering pixels in an image based on color and intensity, we can distinguish different objects and features. And let's not forget anomaly detection. Clustering can identify unusual patterns in data, helping to detect fraud in banking transactions or spot network intrusions. So whether it's recommending your next favorite movie, targeting a specific customer group, distinguishing objects in an image, or identifying unusual patterns, clustering plays a crucial role in many industries. Let's quickly recap what we've learned about clustering. Clustering, a subgroup of machine learning, is the process of categorizing data into different groups or clusters based on their similarities. It's like organizing a vast library of books into different sections according to their genre. We delved into the process of clustering, which involves several steps. Starting with the selection of a suitable algorithm, we then feed it our raw data. The algorithm does the heavy lifting, identifying patterns and similarities to form the clusters. But why does clustering matter? Its applications are broad and impactful. Clustering helps us make sense of vast amounts of data, from identifying patterns in DNA sequences to customizing your movie recommendations. It's a powerful tool in our data-driven world, providing insights and personalization in various fields. Next time you get a movie recommendation or music suggestion, remember, it's all thanks to clustering.